Many astronauts are coming back from long-duration missions to ISS with diminished vision, and Station Science is working to understand why. Station crew members take part in the Ocular Health experiment, gathering data on the eyes and weightlessness so scientists can determine what's causing the vision loss and develop countermeasures. Last week, my colleague Brandi showed us how the crew members conduct an examination using a tonometer, and today she reports on eye exams using an ultrasound.
Hi, welcome back to the Medical Simulation Laboratory just off-site at Johnson Space Center in Houston, where we have learned recently a little bit about some of the different ways that we're finding out about what happens to astronauts' eyesight when they're in space. We're back today to learn specifically about the ultrasound that the crews perform, to learn more about that. And we have with us today Dr. Ashot Sargsyan, who is an ultrasound imaging expert and also one of the investigators on several of the studies that are looking into that. So thank you so much for joining us.
Pleasure to be here.
All right, well, so why don't we start with, why do we do ultrasounds on astronauts' eyes in space?
Well, ultrasound is one of the imaging modalities that we use on astronauts before, during, and after missions. And this modality is very good for portability, non-invasiveness, and it's very informative while looking at a specific organ we're talking about, the eye. It was one of the first devices that we used for this problem, and the reason being it is just best suited to look at certain areas of the eye and best suited for some measurements that we can conduct. And in general, ultrasound is easily transmittable, so we can get a real-time video from the space station. We can guide the crew members during the procedure, actually. We do not use too much time doing it. But most importantly, again, is the information that we derive out of those images.
What kind of information do you get?
The information received by ultrasound imaging is twofold. One aspect of it is structure or anatomy. Using the eye model here, I can demonstrate. We measure, for example, the distance between the very front of the eye and the back of the eye. This way, we can monitor this distance, and turns out in some crew members this distance becomes shorter during the mission, progressively shorter, and if this distance becomes shorter, the subject needs to wear the reading glasses to see well. Okay. And some subjects who use glasses for distant vision have to throw them away because they don't need them anymore because this distance is naturally shorter. So there is some silver lining in some crew members, but generally it's a sign of concern.
So I know you've done a number of these exams, or had the crew do a number of the exams on orbit. Have you been able to collect some good data so far?
Besides looking at the anatomy and structure, we also look at physiology in broader term. Specifically, we look at the flow of blood in and out of the globe. We have multiple vessels, as you can see on this model. And the reds are arteries, and the yellows are nerves, actually. But there are 4 veins coming out of the globe. And then there is a pair of vessels that comes out through the optic nerve, right in the central canal of the optic nerve. So these are tiny, tiny vessels. Those are less than 1 millimeter in diameter. Mm-hmm. However, this technology allows us to accurately describe the character of the flow inside those vessels and the actual velocities of flow of the blood. Mm-hmm. This is more scientific aspect of ultrasound imaging, where we're trying to tie the changes in the eye to the changes that the body in general undergoes, including shift of fluids, including some swelling of the upper part of the body and difficulty in venous drainage from some parts of the body, including the eye. Mm-hmm. So that's one of the hypotheses, that one of the multiple factors we're dealing with is the changes in the blood flow.
Can you tell us what we're looking at here?
This is the ultrasound scanner, actually an exact copy of what we have on the International Space Station. It's one of the most used research hardware, actually. We fly it these days. You can notice that the keyboard is, unlike most medical devices, it's very colorful. There is a reason for that. We have made it color-coded so that we can remotely guide the crew members to the right button more easily. For example, this would be a purple 2 up, this would be a pink 2, this would be a green 4, and so on.
Okay.
So it makes the remote guidance much easier to perform.
Why don't you show me what we do with this?
All right, you're in a position similar to an astronaut about to be examined on the International Space Station. And there will be a second astronaut to assist with the machine and so on. So I will be the assisting crew member in this case. I'm handing you a probe already with gel, a thin layer of gel. And you take off your glasses and center yourself relative to the screen. Do a chin up position with the probe going onto your upper eyelid. Gently ease it on the upper eyelid without any pressure. Once you apply the probe, we can see the circle, the black circle on the screen that takes up most of the image is the eye globe actually. You can appreciate the curvature of the back of the eye. And now if you tilt the probe with the cable end of the probe towards your feet very, very slowly. There we go. That's a very good view. The optic nerve coming and meeting the eye. Here is where the 1.2 million nerve fibers are located in the bundle here in the central part of this stripe. But we're very interested in the gray zone in both sides of this dark stripe, which is the space that communicates with the intracranial space. And pressure inside the skull propagates all the way to reach the globe here. So this diameter is very important. Also important is the distance between the front of the eye and the back. So flattening, shortening, and widening respectively for these three values tell us that something's going not perfect with the given subject.
Well, how does my eye look?
Your eye looks perfect, gorgeous, and unchanged.
All right. So have you been able to draw some conclusions based on what you've learned so far?
We do see changes in the structure. We do see some progression and regression as the mission continues and gets completed eventually. Most of the changes return back to their pre-flight levels. We do see, for example, change in the curvature of the back of the eye. We call it flattening, although it's not really flat in most cases, but it's flattening of the back of the eye, which may be an indicator that there is a disbalance between the pressures inside the globe and behind the globe. The fact is that the space between the sheath and the nerve itself is pressurized, and the pressure equals the pressure inside the skull. So if the intracranial pressure rises, that reflects the pressure propagates all the way to the globe, and therefore changes the balance of pressures right at this interface. So one of those things that we can describe well with ultrasound is that shape of the back of the globe and the diameter of the nerve. So those things together, combined, tell us something is happening.
Okay, so based on that, what you've already learned, what do you do next? Do you keep gathering the same data or add to it, or?
We do this and produce data for flight surgeons to use immediately. So the immediate use for the data, at least some of the data, is part of the clinical practice of space medicine nowadays. So the flight surgeon looks at those numbers and looks at the trends and somehow modifies the surveillance intensity, how frequently they look, do they do additional testing in shorter time intervals, and so on. So that's the immediate clinical monitoring of the crew member. However, the long-term analysis of the cohort as a whole will give us more information about factors of predisposition. Why do some crew members develop vision change and others don't? And finally, we correlate our ultrasound imaging data with other data. So we have a suite of different diagnostic methods. So we have the luxury of statistical analysis that tells us pretty individualized picture of what's going on. We do need more subjects, though. So that scientific aspect of this work will take some time. But papers are already coming out.
All right. Well, thank you so much for talking with us. Again, this was Dr. Ashot Sargsyan, who is an ultrasound imaging expert and one of the principal investigators of several of the studies looking at astronaut eye health. Thanks again for joining us.